Question reads, an investigator is interested in the long-term effects of preschool programs on low-income children. A study was conducted whereby two groups of children were followed over time. The first group of 61 children did not attend preschool. The second group of 62 children from similar areas and with similar backgrounds of those in the first sample attended preschool as 3 and 4-year-olds. The need for social programs as adults was the outcome of interest. Of the group who did not attend preschool, 49 of them needed social services between the age of 18 and 30. In the preschool group, 38 required social services. So your 61 children did not attend preschool, 62 children attended preschool. So let us say we have two groups, no preschool, and we have preschool. We'll have total and we will have favorable. So 61 did not attend preschool, 62 attended preschool. And so for out of those who did not attend preschool, 49 of them needed social services. And on the other group, 38 required social services. So I'll calculate my P1 cap, 49 by 61. P2 cap is 38 by 62. And now going further, we have to calculate. So in the preschool, 38 required social services in the same age range. So now let us suppose I have to calculate my Z statistic for this. I'll directly put my values in this formula, but before that, I need to show you how to calculate P cap. So if we calculate P cap, I told you it's 49 plus 38 divided by 61 plus 62. Let's see how much this comes out to be. Point 0.707. Now I finally calculate my V value. So it's going to be divided by 61 minus 38 divided by 62. Divide this by the square root of 1 minus 0.707 into, you do 1 upon n1 plus 1 upon n2, so 1 divided by 61 plus 1 divided by 62. Approximately, this comes out to be 2.31. And based on your confidence level, you have to calculate your critical Z value. Now, this is going to be a double-sided test because we are basically, if you see the alternate hypotheses here, what we discussed, it's P1 minus P2 not equal to 0. This is my alternate hypothesis. So accordingly, we will be doing the calculations. So if I had to again do it at 95% confidence level or 0.05 alpha, I have to again compare this with 1.96. But because this is greater, we can clearly surmise that there is a distinction between the two sample proportions taken from the two populations. And in a similar way, we can calculate our confidence interval for the difference of the sample proportions using this equation. So now let us suppose that I don't want to do all these calculations manually, and in R, I want to basically reach to all of these conclusions using one statement. Is there a function that can do that? And the answer to your question is yes. There is a function in R which can accomplish all of this using just one line. And that function is called prop.test. So basically in prop.test, you have multiple arguments. The prop.test accepts outcomes in favor, total outcomes, confidence level. Alternative can be two-sided, less than or greater than as per your test. By default, it is two-sided. So if I have to give the values of this particular question, I have to give. So I had 49 and 38. '61 and 62. And confidence level at 0.95. I'm sorry, I have to give a vector C. So if you can see, this is how it will yield out the result. So it will give you the x squared value. It will give you the p value, which you can see is 0.04532, which is less than 0.05. So directly you can come to a conclusion here, and you can say that I can reject my null hypothesis, and there are differences between the samples taken from the two populations. You'll get the 95% confidence interval as well. So this is how you can get your result using R, using prop.test, which is the function that basically calculates your one sample and two sample test for proportions. So this brings to our conclusion of this topic of statistical inferencing. In the next session, we'll be looking over effect measures. Thank you.